Okay, let's do a new one. Uh, a very interesting kind of looping, uh, what's called as recursive iteration. Okay, it's really very interesting, and it can become a little bit difficult to follow. So let's actually do it and see. Uh, Basically, a recursive function is one when that function is called based on a function, based on a condition, it keeps calling itself. Okay, so if the function is let's say f, so from let's say main I call f. Within f there is a condition checking. If the condition is not satisfied, it again calls f. So f calling f, and once this condition is satisfied, it keeps returning back. Now that is called recursion, and this type of function is called a recursive function. Okay, so let's actually see. Uh, the problem is, let's say we have to find the x to the power of y. Okay, so basically exponents, powers. So uh, x could be any number, let's say int, and y could be any int. Okay, so uh, for example, let's say 2 to the power of 2 to the power of 3. Now this will be equal to what? 2 into 2 into 2, which is equal to 8. Okay, great. Now here remember, this is again a maths problem, so we need to be aware of the rules of exponentiation and all that. Similarly, another example could be, let's say 2 to the power of minus 3. Now this will be equal to 0.125. Okay, so it could be tricky. Okay, so let's start off. Okay, hash include iostream.h. Okay, hash include conio.h. Okay, and void main. Right, we are going to keep it simple initially, directly get into main. Now remember, since the exponentiation can go into decimals, we need to use a float, and we are going to put a restriction saying ki base can be float, but the exponent has to be an int. It can't be again a decimal. So exponents can't be uh, decimals. So in which case we will have float x, okay, int y, okay, and let's clear the screen. Let's take the inputs. Cout, enter the exponent, cin. Okay, great. Now cout what we are going to do is we are going to say x, so whatever is the value of x, it will be displayed. And see, I can't directly show exponent, I can't take the exponent to above x, so I'm going to use this symbol to represent exponent. Okay, y, okay, and then equal to, and then I'm going to call a function. Now let's call this function as exponent. And what are we going to pass? We are going to pass x and y, right? And end line. Okay, so my main program becomes very simple, right? Main thing here, apart from all the other input and all those is concerned, is just the call to this function. Okay, so let's write the function float exponent. Okay, float, it will accept a variable called a, and int, let's say n. So here we are going to take it as a and n. Okay, so now what we are going to do is immediately check whether a is equal to 0, right? So a to the power of 1, a to the power of 2. So if a is 0, so 0 to the power of anything is 0. So we have to return, we can directly, without bothering to do any kind of processing, we can just directly say return 0. But remember, we have to return a float. So we can't just return 0, we have to return 0.00 or 0.0. Okay, else, now the other special case is that if n is equal to 0, if n is equal to 0, then what happens? So if n is equal to 0, then remember, anything to the power of 0 is 1. So again we have to return 1 as a float. So we'll return 1.0. Okay, else if n is greater than 0, right? If n is greater than 0, we are going to return what? We are going to return a into exponent of a and the previous previous so if it is 2 to the power of 3, so since once we have already multiplied by a, now we have to multiply it by one less number of a's. So here n represents the number of, so n minus 1. Okay, right? So let's keep going forward. Okay, return. Now if it is less than 0, if n is less than 0, that means in the exponent you have a negative number. So in that case, the whole thing becomes a 1 by, right? So whole thing can be taken into the denominator. So again, same thing, the only thing is instead of just saying a into that, we have to say 1 by a into exponent a comma. Now what happens? Because it is negative, we have to, if we want to reduce it, we have to say plus 1, right? So basically what should happen is this should keep getting reduced. See, this n plus 1 is going to another execution of the exponent function. So there it is going to be taken as n itself. Similarly, n minus 1. So let's say 2 to the power of 3. So here 2 into, again this function is being called. Now a is 2. Now this becomes 2. So again it comes here. 2 we already have. So 2 into, again this is being called. So that's how. And now what happens? Third time when it is called, it becomes n minus 1. That is 2 minus 1, 1. So one more time a is multiplied. Now next time when this is called, it becomes 1 minus 1. So which is 0. So if it is 0, this returns 0. So return. So it returns. Okay. So here it will return what? It will return the result, final result. Okay. Let's actually run it and see what happens. Now remember, here we have to give the prototype. Okay. So prototype of the function. So let's give exponent, float and int. We don't have to specify the variable names because we don't know what variable names are going to be there at this point in time. Okay, so let's run this. Okay, now here closing bracket. Okay, second closing bracket is required. Let's run this again. Again a closing bracket is expected. One more, because now we have 1 by. Okay, great. Enter the base 2, enter the exponent 3. Okay, we need to ask it to wait. Seems to be in a hurry. Okay, base is 2, exponent is 3, 2 to the power of 3 is 8. Now we know 2 to the power of 10 is 1024. So 10 is 1024. Perfect. Okay. Similarly, 2 to the power of 9 is 512. Great. Now similarly, let's give a negative number. So let's say minus 2. Right. So it becomes 1. So 2 to the power of minus 2 is 1 by 2 to the power of 2. So 1 by 4. 1 by 4 should be actually, okay. So now there seems to be a problem. Anyhow, let's try again. 2 to the power of 0. Anything to the power of 0 is 1. Okay. 0 to the power of anything should be 0. So all this is fine. The problem seems to be a negative exponent. So 2 to the power of minus 3, what comes? 0. Why? It is taking the base as 0. Why? It is taking x as 0. Why? Okay, let's run this again just in case. Let's say base is 2, exponent is minus 3. 2 to the power of minus 3 is 0.5. No, 2 to the power of minus 3 is 0.125. Enter the base. Let's say 2 and 3. Wow, seems to be creating problems. 0 to the power of 3 is 0. I think there is some problem. Let's try to figure out what the problem is. Okay, float x equal to 0.0. Let's initialize it properly. Int y equal to 0, x to the power of y. Okay, float A. Okay, let's run this. 2, 3 to the power of 3, 8. 2, 3 to the power of 8. 3, 3 is 27. Let's say 2 to the power of minus 3 is 0.5. Let's see, 2 to the power of minus 3 is 0.5. 3 to the power of minus 3 is 0.33333. Okay, it is giving it as okay, let's increase this to 0.000, and now let's see. Okay, so now base is 2, exponent is minus 3. Okay, there must be some problem, so let's try to figure out. Okay, unable to make out what the problem is. Let's follow one of our tricks. Let's display some intermediate values. Each time exponent is called, let it display the value of a and n. So let it display a and n, and let it do it every time it's called on a separate line. Okay, so 2 to the power of 3. Great. So 3, 2, 1, 0. Okay. 3 to the power of minus 3. Okay, great. And 2 to the power of minus 3. Okay, so this part is perfectly fine. So the only problem is in this particular return. So I think here itself some problem must be there. Let's do one thing. Let's remove this bracket. Okay, and see what happens. Maybe it is just a question of order of operations. 2 to the power of minus 3. Yes. Okay, so 0.125. Let's say 3 to the power of minus 3, 0.037. Yes. So that solves our problem. Okay, let's save it and let's quit.